is the idea that even if there are an enormous number of planets, only ours has life and intelligence. And there, the story is open.
What if the moon isn't just a dead rock in the sky, but something placed, constructed, or even designed? New discoveries are challenging our most basic assumptions about its origin and purpose. Strange internal structures, unexplained energy signatures, and gravitational anomalies are forcing scientists to reconsider everything. Even Carl Sagan, a champion of scientific skepticism, once said, "We must be open to the universe in ways we cannot yet imagine." Could the moon be one of those ways? In this video, we explore a revelation that might reshape not only science, but the story of humanity itself. To go to the moon would cost around $100,000 a pound. That's the estimate still often quoted when discussing modern lunar missions. It might sound extreme, but when weighed against the potential discoveries, that figure becomes a gateway rather than a barrier. The Chinese space program
To go to the moon would cost perhaps $100,000 a pound.
Yeah.
The Chinese have announced that they're going to go to the moon. In fact, they will probably beat the United States. NASA last year admitted that their time frame is behind the Chinese time frame.
has announced its intention to return to the moon, and many analysts believe it may achieve this goal before the United States. Even NASA has publicly acknowledged that its timeline is behind. While that development may seem like a competitive race for national prestige, something much larger is quietly unfolding in the background. It started during a space science symposium in Geneva. On stage was Dr. Michio Kaku, a well-known theoretical physicist and futurist. He has long been a public figure, known for making complex science accessible. But this time, his tone felt different, measured, but urgent. His presentation was titled, "The Moon, a Paradigm Shift in Understanding." Many expected a deep dive into colonization plans, historical lunar data, or discussions about future exploration technologies. But what unfolded was far more surprising. Before starting, Kaku pointed out that the public tends to think of the moon as a familiar, unchanging object. It's the same face we've looked up at for thousands of years. It's there during harvest festivals, eclipses, and bedtime stories. But according to Kaku, new data has emerged that challenges what we thought we knew about it. This wasn't science fiction. It was based on imaging, gravitational modeling, and cross-reference findings from multiple space agencies. At the core of the findings was a new imaging technique, quantum deep imaging, combined with advanced gravitational lensing and radar scanning. These techniques, developed by international teams, offered a much more detailed look at the moon's internal structure than ever before. Unlike previous scans, which were limited by older instruments and assumptions, these new systems detected things that didn't line up with current geological models. One of the first key discoveries was about the moon's internal density. For decades, scientists have worked with a model that estimates the moon's mass and core composition based on seismic data from the Apollo missions and subsequent calculations. However, the new imaging revealed inconsistencies. Specifically, the moon's internal mass distribution did not appear to match up with what we'd expect from a natural celestial body formed from planetary debris. Instead, vast internal cavities were detected, some stretching for hundreds of kilometers beneath the surface. Initially, these might have been written off as lava tubes or hollow spaces left behind by ancient volcanic activity. But it wasn't just the presence of voids that caught attention. It was their layout. The cavities appeared to be symmetrically arranged and evenly spaced. In geological terms, that's rare. Natural formations don't often present themselves in regular geometric patterns. Yet these structures beneath the moon's crust seem to suggest not only symmetry, but also design. At this point, Kaku was careful not to jump to conclusions. He made it clear that the data did not offer definitive proof of artificial origin. Still, the patterns were difficult to explain through traditional geology alone. The next layer of complexity came from thermal imaging. Sensors had picked up unnatural heat signatures emanating from specific points beneath the surface, especially from the areas where these voids were most concentrated. What made this discovery even more puzzling was that the heat didn't correlate with what scientists would expect from the moon's residual formation energy or minor volcanic activity. Instead, the thermal patterns bore a resemblance to something else entirely: dormant but still active reactor cores. Cross-verification from 3 independent space agencies helped confirm that the heat was real, not a glitch. The consistency of this thermal emission across different imaging systems raised difficult questions. If these temperatures were not caused by natural heat sources, what was generating them? And more importantly, how long had they been there? At this stage, Carl Sagan's earlier contributions to lunar studies become relevant. While Sagan is most often associated with planetary exploration and the search for extraterrestrial life, he also participated in early studies focused on lunar contamination and organic detection. He had stressed the importance of ensuring that the moon remained uncontaminated by human activity, so that any indigenous material, organic or otherwise, could be studied in its natural state. In that context, the discovery of unusual internal heat signatures isn't just about geology or engineering. It also raises concerns about what might be present in those cavities and whether we might risk damaging or misinterpreting them if we rush in without proper preparation. Sagan also warned repeatedly throughout his career about the need for scientific restraint. He was known for the phrase, "Extraordinary claims require extraordinary evidence." That principle seems especially important here. Kaku didn't claim aliens built the moon. He didn't say there were machines buried under the surface, but he did say that the existing natural models could no longer fully account for what was being observed, and that means we may have to update our understanding of lunar formation entirely. Adding to the mystery were gravitational anomalies. These aren't new. Small irregularities in lunar gravity were recorded as far back as the Apollo missions. Often they were attributed to local terrain, denser rock formations, or instrumentation errors. But now, new data allowed those anomalies to be mapped in far greater detail. What emerged was a pattern, a grid-like distribution of gravitational variance that stretched across large sections of the moon's surface. Remarkably, this gravitational grid aligned with the same regions where geometric cavities and heat signatures had been found. This correlation between subsurface structure, thermal energy, and gravitational fluctuation suggested that these weren't isolated features, but part of a larger system. Kaku didn't speculate on what that system was. He focused on the consistency and repeatability of the findings. The instruments had been tested and retested. The data had been confirmed. And even though we still didn't know what we were looking at, the evidence was becoming harder to ignore. Some scientists propose that the moon may contain internal mass distribution patterns that are not random. This could indicate that certain regions are denser, potentially containing unknown materials or even engineered components. While the notion of engineered mass distribution may sound far-fetched, it's not without precedent in human engineering. We regularly build satellites with precise internal balance for stable orbit. If a past civilization or an unknown natural mechanism had done the same on a planetary scale, the result might look surprisingly like the moon we see today. Kaku was cautious, but his message was clear. The moon may not be what we've always assumed. That doesn't mean it was built or placed or used as a machine. But it does mean we're likely missing something fundamental. For too long, we've taken its presence for granted, assuming that just because it's always been there, we fully understand it. The findings he presented don't offer final answers, but they do open a wide set of new questions. What are those cavities for? What causes the consistent heat signals? Why does the gravitational grid appear structured rather than random? Following Michio Kaku's surprising data presentation in Geneva, the conversation quickly shifted from pure physics into something broader, touching history, myth, philosophy, and even evolutionary biology. While Kaku himself never stated anything outright about the moon being artificial, the implications of the data were difficult to ignore. Symmetrical voids beneath the surface, structured heat signatures, grid-like gravitational anomalies. These are not hallmarks of typical planetary bodies. At the very least, they suggest a level of geological organization that doesn't occur by chance. Kaku did not stop at just the physical data. He opened the door to historical inquiry, noting that for centuries, many ancient cultures described the moon not as something that was always in the sky, but as something that arrived. This may sound outlandish at first, but it is surprisingly well documented. Civilizations as far back as the Sumerians and as geographically distant as the Mayans, the Greeks, and some Aboriginal Australian tribes have stories that either imply or directly state that there was a time before the moon. Of course, modern science has long considered such stories to be metaphorical, ancient ways of explaining the unknown. But with new data in hand, those same accounts are being looked at in a new light. Were these simply myths, or could they be fragmented memories of real events, interpreted through the lens of early human consciousness? This is where Carl Sagan's ideas become useful once again. Sagan spent much of his career bridging the gap between myth and science, not by validating folklore outright, but by encouraging a balanced, open-minded investigation of its roots. He recognized that ancient stories could contain encoded knowledge, an early form of observational science. In that spirit, the sudden global attention to lunar mythology doesn't seem like a regression to superstition, but rather a reframing of historical narratives in the context of new information. One of the most often cited coincidences regarding the moon is its size and position relative to Earth and the Sun. From our planet's surface, the moon and the sun appear almost exactly the same size in the sky, which is why total solar eclipses are possible. It's an unusually precise match, and no other planet-moon pairing in the solar system displays this same characteristic. Astronomers have historically described this as just a remarkable alignment of size and distance. But now, the word coincidence is being reconsidered. Kaku pointed out that if the moon had been placed, by natural forces or otherwise, its role in Earth's stability could not be overstated. It regulates tides, keeps our axial tilt relatively stable, and contributes to the long-term climate rhythms that have helped life flourish. Without it, Earth would wobble unpredictably, likely leading to extreme climate swings. It's not just convenient that the moon is there, it may be necessary for life as we know it. This observation is supported by research in evolutionary biology. For instance, tidal pools, which depend on the moon's gravitational pull, are thought to be one of the key environments where complex life may have first developed. The cyclic motion of the tides would have forced organisms to adapt to changing conditions, dry land, salt water, fresh water, and may have triggered evolutionary jumps that wouldn't have happened otherwise. So if the moon plays such a crucial role in Earth's environmental and biological systems, is it possible that its position and size were more than accidental? That's a question most scientists still hesitate to answer. But what's changing is the willingness to ask it without ridicule. Carl Sagan believed that science must remain open to new possibilities, even those that initially appear strange. In his writing, he warned against the dangers of arrogance in science, the idea that we already have all the answers, or that anything unfamiliar must be impossible. He called for humility, not just in the face of the vast cosmos, but in how we interpret our own origins. Sagan also addressed the concept of ancient extraterrestrial influence. While he was famously skeptical of the more sensational claims, he never ruled out the possibility that intelligent life could exist elsewhere and may have influenced Earth in the distant past. What he demanded was rigor. Extraordinary claims require extraordinary evidence, he said, and it's that principle that now guides this new wave of lunar inquiry. After Kaku's presentation, scientists and historians alike began combing through archives, re-examining lunar seismic data, old myths, and ancient calendars. One area of renewed interest was the apparent age of the moon. Traditional models suggest that the moon formed after a Mars-sized object collided with early Earth, causing debris to coalesce in orbit. But radiometric dating of moon rocks has sometimes suggested that the moon is older than Earth's crust. This has been a source of confusion for decades. If the moon predates Earth's current surface, it complicates the impact formation theory. One interpretation, still speculative, is that the moon didn't originate from Earth at all, but arrived later, possibly from elsewhere in the solar system. Another more radical idea is that it was introduced deliberately after Earth had stabilized. That concept may sound far-fetched, but Kaku's thermal and gravitational data do not fit neatly into existing models, prompting many to revisit even the most basic assumptions. There are also cultural patterns that seem too consistent to ignore. Ancient societies all over the world viewed the moon not just as a physical object, but as a living presence. It played central roles in rituals, agriculture, navigation, and storytelling. Lunar calendars were among the first systems humans used to track time, and the moon's cycles influenced religious ceremonies and seasonal farming. While some of this is clearly practical, the moon is visible and predictable, there's an undercurrent in these traditions suggesting something deeper, almost relational. Kaku didn't dwell on this aspect, but he acknowledged it. He noted that the moon's influence on human consciousness and culture is likely not accidental. Even if it turns out to be entirely natural in origin, its role in human development, physical and psychological, has been profound. And if the moon was placed or engineered, that influence takes on a different meaning entirely. It could suggest intent, not just mechanical purpose, but a designed interaction with life on Earth. Again, this is where Sagan's measured perspective becomes useful. He wouldn't have supported jumping to conclusions, but he likely would have encouraged the investigation of these patterns, especially if supported by measurable data. In his view, science and wonder were not opposites, they were companions. The real danger was dismissing new questions just because they didn't fit existing frameworks. So far, none of the anomalies presented by Kaku prove anything definitive, but the cumulative weight of the evidence has started to change the tone of the conversation. What was once dismissed as pseudo-archaeology or mythological fantasy is now being reconsidered as part of the data landscape. That doesn't mean accepting fringe theories. It means allowing for new models where the old ones no longer apply. This new line of thought doesn't center around physical mechanics or orbital data. Instead, it's about resonance, perception, and the possibility that the moon may in some way influence human consciousness. What was once purely metaphorical, phrases like lunacy or being moonstruck, is now being revisited in light of neurological and quantum research. Recent efforts by interdisciplinary teams, including physicists, cognitive scientists, and even linguists, have led to experiments designed to test whether the moon has any measurable effect on brainwave patterns or altered states of awareness. One such initiative, quietly funded by a group of universities and private research institutions, has begun conducting experiments using rhythmic light pulses and low-frequency magnetic fields. These inputs are designed to mimic some of the frequencies observed in lunar electromagnetic data, particularly from the regions showing thermal and gravitational anomalies. Volunteers are exposed to these fields while their brain activity is monitored. The participants are not random. They are selected based on heightened neurological sensitivity. This includes individuals with rare EEG patterns, savants, synesthetes, or those reporting naturally vivid dream states. These aren't pseudo-scientific tests. The procedures follow rigorous double-blind protocols, and results are analyzed using mainstream neuroscientific tools. What has emerged so far is intriguing. Many subjects report strong internal visual imagery during the exposure sessions, often geometric in nature. Others describe experiences that resemble memory flashes, but of events that they cannot place within their own life. Some describe emotional surges that feel significant but have no clear origin. A few report shared symbols or imagery, even though they were tested independently and in isolation. This leads to a controversial but increasingly discussed theory that the moon might act as a resonant interface, not conscious itself, but structured in a way that allows for some kind of interaction with biological intelligence. The concept is far from being mainstream, but it is gaining quiet traction among researchers exploring the boundary between physics and consciousness studies. Carl Sagan himself never explored this exact idea, but his broader work in the field of astrobiology set the stage for such questions to be considered scientifically rather than mystically. He often discussed the possibility of life forms or systems operating on levels humans might not yet understand. In his writing, Sagan emphasized that a truly advanced civilization would not necessarily communicate through language, radio, or even mathematics as we know it. It might use patterns, frequencies, or entirely novel dimensions of interaction. That perspective is relevant here. If, as some hypothesize, the moon contains structures that emit or modulate electromagnetic or quantum fields, it is at least within the realm of possibility that those structures could influence neural activity, especially if designed to do so. One group of researchers, drawing from cymatics and quantum entanglement theory, have proposed that certain surface patterns on the moon might function as a kind of planetary scale encoding system. Crater alignments, shadow formations, and elevation groupings may seem random at a glance, but when mapped mathematically, they begin to show repeating ratios, harmonic patterns consistent with resonant systems. If these are deliberate, they could represent a form of non-verbal signaling or even a passive communications system that interacts with biological rhythms on Earth. This may sound fantastical, but it aligns with a growing body of research that looks at how consciousness itself might be sensitive to environmental factors we have yet to fully map. Just as the human body reacts to magnetic fields, light patterns, and sound frequencies, it's plausible that the brain might also respond to specific spatial geometries or long-range resonant fields. This is not to say the moon is a machine in the way we typically imagine. Rather, it might act as a kind of mirror or amplifier, possibly constructed, possibly natural, but fine-tuned to interact with the specific environmental and biological dynamics of Earth. In this sense, the moon becomes not just a regulator of tides or seasons, but a co-evolving partner in the development of life and consciousness. Sagan might not have supported the leap to claiming any sort of interface, but he would have supported asking the question. He often reminded his audiences that science loses its power when it refuses to look beyond the current paradigm. What matters is evidence, repeatability, and a willingness to rethink assumptions when new data challenges them. It's not only consciousness researchers who are exploring this space. Astronomers and physicists are revisiting the long-standing mystery of transient lunar phenomena, brief flashes or glows on the moon's surface. These have been reported for centuries, and though often dismissed as optical illusions or reflection artifacts, they are now being reanalyzed using high-definition imaging. Some of these flashes align with the same zones that exhibit unusual thermal or gravitational data. That overlap raises questions about internal lunar activity, perhaps even signaling behavior or energy fluctuations that follow patterns we haven't yet decoded. Another mystery involves lunar seismology. Unlike earthquakes, which dissipate quickly, moonquakes have a strange tendency to reverberate. They can ring through the moon's body for hours, a property that some scientists have likened to striking a hollow object. While this was previously attributed to the dry, rigid nature of the lunar surface, recent seismic modeling suggests that the reverberations might also indicate internal lattice structures, chambers or supports that aren't accounted for in natural formation models. Put together, these observations paint a picture of a body that is far more complex than once believed. Its internal dynamics do not align cleanly with our expectations, and the more we learn, the more deliberate its composition seems. Whether natural or artificial, the moon appears to be a node of information, not just an inert rock orbiting Earth. From a philosophical standpoint, the implications are far-reaching. If the moon plays a role in shaping or even guiding the evolution of life and consciousness on Earth, then our understanding of human development would need a complete revision. The moon would no longer be just a backdrop to human history, but an active participant in it. Cultural responses to this idea have already begun to appear. Artists, writers, and filmmakers are exploring the concept of the moon as a presence rather than an object. Music inspired by moonquakes, paintings of lunar energy fields, and speculative fiction that imagines the moon as a guardian or observer have all emerged in the wake of this renewed interest. Educational institutions are starting to pay attention too. New interdisciplinary courses are emerging that combine planetary science with anthropology, cognitive theory, and mythology. The goal isn't to chase fantasies, but to recognize patterns, test ideas, and pursue data wherever it leads, even into areas that once seemed outside the domain of serious science. Sagan often described science as a candle in the dark. He believed that its true strength lay in its ability to evolve, to adapt, and to admit when it didn't yet have all the answers. That philosophy is what allows us now to take these new questions seriously, not because we know the answers, but because we finally understand that not knowing is where science begins, not where it ends. The technological implications of the moon's newly discovered anomalies are beginning to drive an entirely different kind of exploration. No longer are space agencies and private companies simply focused on resource extraction or building lunar bases for habitation. A growing number of proposals now focus on what might be hidden beneath the surface, deep below the regolith and layers of debris, in places where anomalies suggest the presence of materials, structures, or even systems that could be remnants of something designed. Seismic experiments are being reimagined. Rather than focusing solely on crustal composition, the objective now is to identify internal resonant patterns that may indicate buried chambers or engineered lattices. One initiative proposes deploying seismic pods into these anomalous regions, paired with micro-scale explosive charges to map the moon's internal resonance signatures with a level of detail never before attempted. At the same time, robotic exploration is evolving. Swarms of nanobots, small, insect-sized machines, are being developed to enter micro-fissures in the moon's crust. Their task would be to gather real-time chemical, magnetic, and structural data from regions where radar scans suggest unusual density or composition. These nanobots would relay findings using magnetotronic feedback systems, potentially uncovering non-natural alignments or materials. The commercial space sector, too, is responding. Companies that previously focused on lunar mining for rare Earth elements are now including technology reconnaissance in their mission objectives. If even fragments of the moon's interior turn out to contain ancient alloys or energy systems, the implications for terrestrial science and engineering are massive. Some of the reflective anomalies discovered via radar and spectral analysis suggest the presence of materials that refract energy in ways not currently understood by modern material science, perhaps even manipulating probabilities or wave behavior on a quantum level. This brings in the concept of quantum mirrors or advanced metamaterials, technologies that could fundamentally alter communication systems, computing, or energy generation. If the moon does contain such materials, reverse engineering even a small sample could fast-track developments in quantum computing, gravitational field manipulation, or even space propulsion. And yet, alongside the excitement of discovery, there is also a growing sense of responsibility. Questions of ethics are beginning to surface in a way they haven't during previous space missions. What if the moon is not just a relic, but a construct with a purpose? What if its systems, whether dormant or still operational, are sensitive to human interference? The scientific community is now beginning to weigh the risks of rushing in, especially if what lies beneath is part of a much larger mechanism or network. Carl Sagan often warned against the human tendency to treat new frontiers as places for conquest rather than understanding. He believed that exploration should be driven by curiosity and care, not greed or national pride. If the moon does turn out to house remnants of an advanced intelligence, then approaching it with humility may be not just respectful, but necessary. This ethical dimension isn't only theoretical. Already there are philosophical debates emerging across institutions. Is it appropriate to mine or terraform a celestial body that may contain ancient systems or artifacts? Should there be a planetary equivalent of a cultural preservation treaty? These questions are no longer limited to science fiction. They're being discussed in policy rooms, university ethics seminars, and international space forums. Meanwhile, some researchers are taking a wider view, one that expands beyond Earth and the Moon. They propose that if the Moon was deliberately placed, then perhaps it's not unique. Other planets in the galaxy may have similar satellites, positioned with care to stabilize climate, regulate biological rhythms, or encourage evolutionary development. In this context, the moon might be one part of a much broader system, a network of life-supporting constructs scattered across space. This model, sometimes referred to as evolutionary guidance theory, suggests that Earth's history of mass extinctions and evolutionary leaps may not have been as random as once believed. If the moon contributed to this process through gravitational nudges, radiation shielding, or even subtle bioresonant interaction, then the emergence of intelligent life may have been gently guided rather than purely coincidental. This doesn't erase natural selection or evolutionary mechanics, but it frames them within a context that includes external influence. The idea is not that humans were engineered outright, but that Earth may have been tuned over time to favor conditions conducive to intelligence and complexity. The moon, in this view, was not just a passive satellite, but an active part of that process. From a scientific standpoint, the search for biological markers within lunar material is gaining momentum. Recent advances in ultrafine spectrography have allowed researchers to analyze lunar core samples with unprecedented precision. In one instance, a carbon nanostructure was discovered embedded in an impact layer dated at over 2 billion years old. While not biological in itself, its complexity and organization suggest a purpose beyond random geological formation. It may have functioned as a data carrier or as part of a degraded organic computational system. These types of discoveries are leading to new fields of study that blur traditional academic boundaries. Astroarchaeology, once seen as a speculative or fringe discipline, is being taken more seriously. Researchers from anthropology, ancient history, linguistics, and materials science are working together to examine ancient myths, cave art, star maps, and even ceremonial architecture, looking for recurring patterns that might align with what we now understand about the moon's anomalies. In doing so, they are not claiming direct contact with alien intelligence. Instead, they are working under the idea that if the moon had an effect on early human development, there may be encoded cultural memories, symbols, rituals, or traditions that reflect an ancient awareness of its significance. For example, in several cultures, the moon is portrayed not just as a light in the sky, but as a guide, a gatekeeper, or a giver of knowledge. These archetypes may contain more than poetic value. They may point to a time when the moon's influence was more visible, or at least more intuitively understood. Public imagination is responding as well. In the months following the initial wave of revelations, artists, musicians, and writers have produced a surge of new work centered around the moon. Exhibits and installations in galleries worldwide have begun to interpret the moon not as a sterile object, but as a presence, something that has shaped human consciousness in ways that are only now being realized. Psychologically, this shift is profound. For generations, the moon has been associated with calm, with reflection, with the tides of emotion and time. If we now begin to see it as a potentially active construct, perhaps even as a repository of knowledge or technology, our collective relationship with it changes. It becomes not just a natural neighbor, but a kind of silent partner in our journey. And perhaps that's the point. As Carl Sagan once said, we are a way for the cosmos to know itself. If the moon has been watching, guiding, or simply existing in a state of silent cooperation with Earth, then our understanding of the cosmos must expand to include the idea that intelligence, in its oldest and most enduring forms, may not always take the shapes we expect. It may not speak. It may not move. It may simply wait until we're ready to notice. Today, As every new scan, drill, or data set brings us closer to understanding the moon, we are not just exploring space. We are exploring the foundations of our own existence. And in doing so, we are rewriting a story that was once thought complete. The moon, long seen as cold and unchanging, now feels alive with questions. It reflects more than light. It reflects a challenge, a quiet invitation to go deeper, not just outward into space, but inward into meaning. And as we take those steps, we do so with the awareness that something far older and perhaps far wiser may have been waiting there all along.